In this video, we have a standard second order circuit. It's a little bit more complicated than the ones we did previously. Everything's already been turned into phasors, so we don't really know what the frequency of the sources are. All we know is that after you've converted things, this is what you get. And we're going to show how we can use our techniques from circuit theory, including node voltage, in order to solve this circuit for the unknown current I0. If you keep watching these videos, you're going to get pretty tired of this circuit, as we're going to solve the same circuit over and over again, but each time with different methods. So you're going to see node voltage, mesh current, Thevenin, superposition, all the old techniques we've seen in previous videos that only worked with resistors are now going to work with resistors, inductors, and capacitors as long as we use phasors. So for this problem, since we're doing node voltage, I've already labeled the nodes V1 and V2. However, because there is a voltage source between them, we are going to have to use a super node here. So if I do KCL at the super node, the current going left, V1 minus ground 0 over the total impedance, 1 plus J. Then I have the next one, the current's coming in, so minus 2. And 2 angle 0 is the same as just 2. Then I have, we do the current left down, the current right down would be V2 minus 0 over the 1 ohm. And lastly, the current going right would be V2 minus 0 over 1 minus J, the total impedance there. So that gives me my first equation. Then we need to use our supernode relationship here to find the second equation. So the positive side is on the right, so that means V2 is going to be a higher potential. V2 minus V1 is really 6 angle 0, but 6 angle 0 is also 6. So what I'm going to do is I'm going to take the first equation, I'm going to multiply by the LCD, 1 plus J, 1 minus J, clear out all my fractions there. On the first one, the 1 plus J cancels out, and we're left with a 1 minus J V1 minus, and that's going to be 2 times that product, but you can actually just work out 1 plus J times 1 minus J is in fact going to be just 2. So 2 times 2 gives me a 4 there, plus 2 V2, and then the last term, the 1 minus J cancels, 1 plus J V2 equal to 0. Then I'm going to go ahead and just get everything in terms of V2, so I'll use the supernode equation over here. Solve for V1, it's going to be V2 minus 6. I'll go ahead and replace that in. So 1 minus J times V2 minus 6 minus 4. I'll combine these two together. It's going to be 3 plus J V2 equals 0. Then I can distribute the 1 minus J in. 1 minus J V2 minus 6 plus 6J minus 4 plus 3 plus J V2. Combine the V2 terms together. That's going to be, it looks like 4, actually minus J plus J, we'll just cancel out, so it's going to be 4 V2. If I move everything to the right side, it's going to be 10 minus 6J. So then when I divide by 4 here, everything's least divisible by 2, so I'd have 5 minus 3J over 2. That gives me my V2, but then I also need to have my I0. Here's what we're looking for. Well, by just doing Ohm's law, that's the difference in voltage, V2 minus 0 over the impedance. Well, the impedance there is just 1, so it's still going to be 5 minus 3J over 2. And if you don't like writing it that way, you can write this as 2.5 minus 1.5J. However, we're really going to want this into polar notation in order to convert it back in terms of time. So we can use our calculator to go ahead and convert that. We're going to get 2.92, 2.91 Doesn't really matter that much. I'll just, 2.9. And then angle negative 30.9, or really negative 31.0. So then that means my I0 of t is 2.9 cosine. Now we would need to put our omega here, but this problem does not give us any omega. All it tells us is what happens after it's converted. So we'll just leave omega here. It's whatever is going on. We don't know it, so we'll leave it as omega minus 31.0. This is everything in terms of amps. And this gives us our final answer here.